Good morning and welcome to day 2 of NASA Television's coverage of the historic first flight test of our new spacecraft Orion, built to send humans farther than we've ever been able to go before. You're looking at a live view of the Space Launch Complex number 37 at Cape Canaveral Air Force Station in Florida, where Orion is sitting on top of a Delta IV Heavy rocket ready to launch in an hour and 5 minutes. I'm Brandy Dean, your host for the flight test today. I'm here in the Mission Director Center about 3 miles down from the launch pad. Orion's going to be going 3,600 miles up above Earth in a 4.5-hour mission that's going to test all of its critical systems that we need to ensure work before we put humans on board. It's going to be, again, a 4.5-hour flight, and it's going to take us farther than any spacecraft built for humans has been in more than 40 years. That sets us up for a high-speed, high-temperature re-entry, 20,000 miles per hour and 4,000 degrees Fahrenheit on the heat shield. It'll be a trial by fire that allows us to test systems that we'll rely on when we do have astronauts on board for the first time. We'll be covering the entire flight here on NASA television from launch, which again is set for 7:05 a.m. Eastern Time, all the way through splashdown in the Pacific Ocean, which would be just before 11:30 a.m. Eastern if we launch on time. The team supporting Orion is spread out literally across the country, and we'll be checking in with many of them in the course of our coverage today. Here with me in the Mission Directors Center, we have the Mission Management Team, which is a collection of program and operation managers from NASA and Orion Prime Contractor Lockheed Martin. They're led by Lockheed Martin Mission Director Brian Austin, and they're going to be the ones making any decisions necessary that if anything comes up that's beyond what's been established in the launch commit criteria and flight rules for the flight test. From here, we're going to go next to NASA Public Affairs Officer Mike Curie, who's just down the hall, keeping an eye on the weather and technical issues that caused us to delay yesterday. How are things looking today, Mike?
Oh, both technically and weather-wise right now. Yesterday, after we scrubbed the launch, a team of NASA and United Launch Alliance and Lockheed Martin managers and engineers met and developed a plan to go through and determine what might have caused the issue. And after they ended up detanking, removing all the liquid hydrogen and liquid oxygen from the common booster cores, it became pretty apparent that the cause of our scrub yesterday with the fill and drain valves was caused by sluggishly moving valves. And that became the case because they sat there immersed in minus 423 degrees Fahrenheit liquid hydrogen for 2.5 hours. Once they drained the tanks, the valves worked fine, and at this point today, we've experienced no issues. We are completely tanked on both the common booster cores, all 3 of them, and the second stage, liquid hydrogen and liquid oxygen. Everything is working well. We're in topping mode. No technical issues of any kind being worked. Earlier today, we were dealing with some weather concerns. We have 3 potential issues in the forecast from 45th Space Weather Squadron, Kathy Winters, Launch Weather Officer. The potential for flight through precipitation, cumulus clouds in the area, and winds in exceedance of 23 knots from a predicted direction of 070. We were fighting rain earlier. At this point, the rain is moving to the south and dissipating. The winds are increasing a little bit. They have been steadily 19 to 20 knots over the last couple of hours. But at present, we are green on all weather constraints, and hopefully we can stay that way as we proceed through the next hour plus and head toward liftoff at 7:05 a.m. Eastern Time. So with that, we're going to go to the Johnson Space Center in Houston, Texas, Mission Control, Houston, where Rob Navius is standing by. Rob?
Thanks very much, Mike. Here in the Orion Flight Control Room, the flight operations team is on console, led by lead flight director Mike Serafin. He took a handover about an hour and a half ago. His team reported no vehicle issues, no outstanding issues with the Orion spacecraft as we are poised for launch. This team to control operations between launch and splashdown out in the Pacific Ocean 4 hours and 23 minutes after liftoff, as well as the powering down of the Orion spacecraft in the Pacific and the ultimate handover handover of the spacecraft to the U.S. Navy NASA recovery team that's on station out there. The Icana unmanned airborne vehicle that may provide us views of Orion descending under the parachutes departed from Edwards Air Force Base in California and the Armstrong Flight Research Center about an hour or so ago. It is en route to the splashdown zone, where the Spaceflight Meteorology Group reports excellent conditions, just some scattered and low clouds, with wave heights expected to be well within limits for the splashdown and recovery of Orion later today. And just one note, as we mentioned yesterday, after liftoff, you'll be hearing the voice of Steve Agate of United Launch Alliance for the first 5 minutes and 50 seconds of the flight, as he provides all of the flight telemetry on the first stage performance of the Delta IV Heavy rocket as it heads uphill. We'll take over commentary here in Mission Control at the 5-minute 50-second point into the flight as we approach the first critical Orion program milestones. And with that, we'll go back to Amber Philman now on the USS Anchorage out in the Pacific for an update on recovery preparations out there. Amber?
Thanks, Rob. I'm out here on the USS Anchorage, one of the U.S. Navy's amphibious ships, and we're currently outside the landing zone about 600 miles southwest of San Diego. Right now, it's still very early out in the Pacific Ocean, so the team of NASA, Navy, and Lockheed Martin recovery personnel are just beginning to wake up before they begin final preparations for recovery of the Orion crew module, parachutes, and forward bay cover. Weather balloons have been launched from the deck of the ship, and the team has been actively monitoring sea conditions. Right after launch, the team will conduct their final pre-task briefing, where they'll address any remaining open items and make sure everything is ready to go. About an hour before splashdown, the helicopters will take off from the ship's deck and fly out to help locate Orion as it makes its descent towards the ocean. Once Orion splashes down, teams in rigid hull inflatable boats will find and secure the hardware with floats until they are able to safely recover them. The weather in the landing zone is currently green. Everything is looking good out here in the Pacific, and we are ready to recover Orion. I'll send it back to you, Brandy, and the Mission Director Center in Florida.
Thanks, Amber. So we're now 56 minutes away from today's launch at 7:05 a.m. Eastern Time. And as you heard there, conditions are looking pretty promising for Orion today. Of course, the launch is only the beginning of the flight test, and actually the hard part for Orion doesn't come until we've made it to space. Over the 4.5-hour flight, we're going to be testing Orion's critical systems, everything from the computers on board and guidance and navigation to the jettison and separation events, and of course the heat shield and parachutes. We call all that Orion's trial by fire, and next we're going to take a look at why.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before, to an asteroid or even onto Mars. For these missions, Orion has to be one tough spacecraft, withstanding high speeds, searing temperatures, and extreme radiation. Before we can send astronauts into space on Orion, we have to test all of its systems. And there's only one way to know if we got it right. Fly it in space. For Orion's first flight, no astronauts will be aboard. The spacecraft is loaded with sensors to record and measure all aspects of the flight in every detail. It all begins with launch aboard a Delta IV Heavy rocket. As it punches into Earth orbit, Orion will jettison its launch abort system. The abort system is a safety feature designed to pull Orion and its crew out of danger if there were a problem with the rocket during ascent. Orion's journey is just beginning. As the spacecraft and the upper stage begin their first lap around Earth, Mission Control in Houston is monitoring the progress of the flight. Orion's over 100 miles up and going about 17,000 miles per hour. Just as it passes over the Indian Ocean, we lose communication. This is expected. The communications link we have through satellites to Orion is momentarily lost, but Orion continues to receive and process data. Its computers can handle 480 million instructions per second. Imagine you are traveling with Orion as the flight test continues. One orbit completed. Time to go. The upper stage of the rocket fires again. Like the setup for a roller coaster ride, this is the big climb we've been waiting for. We are headed 3,600 miles above Earth. 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. .20,000 miles per hour. Air particles pushed out of the way heat up. An envelope of hot plasma surrounds the vehicle as it plummets towards Earth. The plasma reaches temperatures of 4,000 degrees Fahrenheit, almost twice as hot as molten lava. This may be the most dangerous part of the flight. Mission Control is monitoring all the data from the spacecraft, and then we lose communication again. No data can penetrate the plasma. Orion is on its own. Orion is inside a fireball. Onboard systems ignite jets to keep the ship pointed correctly, so the specially constructed heat shield takes the full brunt of the inferno. This is the largest heat shield of its kind ever made. Orion's computers command the spacecraft to bank like an airplane, keeping a precise path to the landing site. Even though we've slowed from 20,000 miles per hour to about 300 miles per hour, we're still traveling amazingly fast. We must slow down to safely land in the ocean. Luckily, we have parachutes. Specially designed for Orion, the parachutes help us hit the brakes, but not too quickly. One day people will be aboard, so deceleration must happen in stages to keep things comfortable for the crew. The forward bay cover jettisons. Two drogue chutes deploy and slow the returning spacecraft down to 175 miles per hour. Then, the three main parachutes open. Once fully engaged, this canopy would cover an American football field. It takes parachutes this size and strength to slow our descent to 20 miles per hour, and then splash. For this first flight, we won't have astronauts inside, but we still have some very precious cargo. The flight data from this mission is stored inside the Orion spacecraft. While our flight might be over, there is still a lot of work to do. Onboard sensors recorded every detail, from launch to flying in space, to re-entry to landing. Flight tests are difficult and complex, but they give us confidence that the systems we have designed work under real flight conditions. It's great to be a part of this first space flight for Orion, and we're looking forward to beginning a new chapter in human space exploration.
As you can see, the real excitement for Orion begins after launch, so we've got our fingers crossed that we'll be able to lift off as planned today. Let's go back now to Mike Curie for an update on how our chances are looking. Mike?
Brandy, everything is still looking great. We are at T-minus 34 minutes, 20 seconds and counting, and 49 minutes away from launch. United Launch Alliance launch conductor Scott Barney just reported to Orion mission manager Brian Austin that they're working no issues whatsoever. Everything technically looks great on both the Delta IV Heavy rocket and the Orion spacecraft. And Launch Weather Officer Kathy Winters has not reported any new weather constraints. We remain green on the board for weather. This is going to be the 8th flight of the heavy configuration for the Delta IV launch vehicle and the 25th Delta IV since 2002, when the first flight was made. The Delta IV is produced by United Launch Alliance in Decatur, Alabama, comprised of the 3 common booster cores that we've been showing you, that you see illuminated brightly, the orange tanks with the white tops, the central core booster, and then 2 on each side, or 1 on each side. Each of the common booster cores is powered by the Aerojet Rocketdyne RS-68 engine, fueled by liquid hydrogen and liquid oxygen. And the Delta cryogenic second stage is powered by the Aerojet Rocketdyne RL-10B engine. The 3 first stage engines each generate more than 650,000 pounds of thrust, equaling more than 2 million pounds at the time of liftoff. And then once we've made it through the first stage, the second stage engine generates 24,750 pounds of thrust to carry Orion on to the rest of its mission. A very powerful rocket, the most powerful rocket that America has in its fleet. With Orion on top, the Delta IV is 242 feet tall, and it weighs nearly 1.6 million pounds as it sits there fully fueled with the gaseous oxygen venting off the top of the common booster cores. You see there the Orion spacecraft ready to make its inaugural visit in space. There is nothing standing in its way at this point to lift off at 7:05 a.m. Eastern Time. Earlier today we were contending with some rain showers in the area, and they still are an issue, but currently on the radar they are popping up predominantly to the south, and they're either dissipating or they are remaining to the south. One issue that we may have to contend with today is winds. And as we had learned yesterday, where the wind is coming from determines what the limit can be. And the more easterly or southerly, the better for us. Coming from the north is not good. And while we have stronger winds today than what we had yesterday, they are coming from a more northeasterly direction, 070, which gives us a higher limit of 23 knots. And hopefully that's enough margin in order to be able to lift off today. The winds that Kathy Winters has been reporting have been about 19 to 20 knots with an occasional peak. And earlier today, about 4:30 in the morning, we were no-go for both flight through precipitation and cumulus clouds rules. The cumulus clouds are associated with rainfall. That's moved out of the way, and when Kathy Winters was briefing the team earlier this morning, she predicted that the rain might dissipate as we went through the launch countdown today, and that would be the good news. The bad news would be that as the sun came up and the temperatures warmed, the winds could conceivably pick up. We'll have to keep an eye on that just to see whether or not we are going to be contending with any of the 3 weather constraints that are in her forecast, which together have given us a percentage, which is a tricky thing to come up with, but the percentage is a 60% probability of violating the weather criteria during launch, or a 40% chance for favorable weather during the 2-hour and 39-minute launch window. But again, everything is go right now. And we'll keep an eye on the status of the Delta IV Heavy. Turn things right now back to Brandy Dean. Brandy?
Thanks, Mike. We heard from NASA Administrator Charles Bolden yesterday on how Orion fits into the big picture, and he is back today with us, making a little bit more time to talk to us and follow up on that conversation.
Thanks for letting me come back again, Brandy. Thank you.
Well, thanks for coming. I guess why don't we start with just if we're able to launch today, what will that mean for NASA?
Well, if we're able to when we're able to launch today, it will mean that we're one step closer to being able to put humans on Orion, because we'll have one more non-crewed mission coming up in 2018 or so. That'll close us out in terms of giving us a comfort level that the vehicle's qualified to carry crew. So then we'll start flying our very first mission. EM-2 is scheduled to be a mission that'll take us into cislunar space. So the area around the moon, the area that we are beginning to call the proving ground. And there we can really begin to exercise some of the procedures and operational practices that we think we're going to need when we get to the area of Mars. If all goes well, when we fly that first human mission, we will have redirected an asteroid from its normal orbit of the sun. It will be now in the orbit of the moon. So astronauts will be able to interact with that asteroid, go down and do operations, such things like determining, can you really attach an astronaut to an asteroid sufficiently that they can do mining types of procedures and the like. So very exciting time ahead when we get Orion off today.
Well, as an astronaut yourself, are these especially exciting missions to think about?
It's interesting. We were having this conversation last night at dinner, and it's incredibly exciting to be at this particular juncture. I'm very fortunate. I came to NASA in 1980, and we were in the lull between Apollo and shuttle. We had not flown since 1975 when we flew Apollo Soyuz. We'd flown 3 Skylab missions, but they were just point missions that we knew once they were done, it was done. So shuttle was supposed to fly in 1978. Here we were in 1980. I was arriving, no shuttle. In fact, I got there as shuttle was flying from its production facility in Palmdale, California to the Cape, losing a number of tile en route. It was a dark day for us. We had actually an engine test go wrong down in Stennis, so things were not quite as bright. But we battled through that. The whole team did around the agency, and then came up in April of '81, and we ended up flying STS-1, which was absolutely incredible. As incredible as that was, it to me wasn't as important as STS-2, because up until that time, no spacecraft had ever been reflown into space. So when Dick Truly and Joe Engle got aboard Columbia to fly STS-2, my heart was beating pretty hard. I was a support crew member for him, but we knew that we hope this works, and we think it's going to work. We've got confidence in everything, but it became the first time we had ever flown a reusable spacecraft. So to me, this is sort of like deja vu. I've been here. I know the end of this story, and I know that this is going to mean incredible success for this agency and this nation. I had no idea that shuttle would go a 30-year incredible run. We have every expectation, though, that this flight today will be the first flight in a long series of decades of flights using Orion and SLS, sending humans to places we've never been before, and just the idea of having a human, in orbit around the moon, interacting with an asteroid. That in itself is mind-boggling, and it's a few years ago I would have said it's inconceivable. It is not, because we are very confident we can do this. And then getting onto Mars is really important, because that's something I talk to my granddaughters about. I have 3 granddaughters, 8, 14, and 12, and we don't talk about trivial things. They talk about living and working on Mars, and it's not a matter of maybe. It is a matter of they are going to do that. And so it's really important to me personally to make sure that I've done everything I can in my capacity as the NASA administrator to make sure that my granddaughters and the granddaughters of a lot of other NASA employees and your kids one of these days, if you got them or when you get them, that they can follow in our footsteps and go do big things.
Well, and I guess, Orion's certainly part of that, but it's not the only part, right? We've got the robotic missions going on to help lead the way.
And, we tend to, several things we're doing today that I think we should stop and pause. One, right now we're focused on the launch vehicle. The Delta IV Heavy, while very important part of this play, that is not the star of the day. The star of the day is Orion. And we don't even get to see Orion come on stage until we launch, get it separated from the launch vehicle and into its 2-orbit flight. So we've got to wait a little while until the prima ballerina comes on stage. I'm saying this because my 14-year-old daughter is dancing the Nutcracker this weekend, so that's another reason we need to get going. But if you look at it like a kid, this is the prima ballerina on top of this incredible monster, the Delta IV Heavy. we're very confident in the Delta IV Heavy, and we want it to do its thing. But its part in the play is pretty short. You know, after about 8 minutes or so, it's done, and it leaves the stage, and on stage comes Orion. And I think we're going to see an absolutely incredible performance from our prima ballerina, and the way that she's going to turn and twist and do stuff that to an engineer is going to be so graceful and so beautiful. And people down here are going to be kind of giddy, and they'll be cheering at every step along the way, because, you know, everything may not go right. But everything that does go right means that we've brought down one more risk on this vehicle, and that's what today is all about. So it's a really exciting day for me personally, for this agency, and I think you know, driving up the causeway, looking at all the cars, I think it's a big day for the world, for people who know and like space.
All right, well, great. And I think that actually today caps off a great year. So next we're actually going to take a look back at some of the highlights of 2014 so far.
Thanks so much, Mike.
Here's a look at some of the top NASA stories of 2014.
That's one small step for man, one giant leap for mankind.
With 2014 marking the 45th anniversary of Neil Armstrong's historic first step on the moon, NASA outlined plans for America's next giant leap in space exploration, to send astronauts to Mars. To prepare for that leap, NASA stepped up development in 2014 of many game-changing technologies and capabilities. The agency worked on solar electric propulsion technology, which could enable cost-effective trips to deep space destinations. Destinations that could include a human mission in the 2020s to an asteroid placed into orbit around the moon by a robotic spacecraft as part of NASA's asteroid redirect mission. NASA plans to announce more specific details in December about potential candidate asteroids and the design of the mission. The successful first flight test in June of the saucer-shaped low-density supersonic decelerator demonstrated an inflatable system that could be used to land heavier and larger payloads than ever before on planets with atmospheres. The International Space Station continued its role as a unique platform off the Earth where astronauts are working for the Earth with biomedical research and with payloads delivered by commercial partners SpaceX and Orbital Sciences Corporation, such as the first 3D printer in space, which could be used to manufacture parts in space. And the addition of an Earth science instrument to the space station's exterior to monitor ocean surface wind speed and direction for use in weather forecasting and for monitoring large-scale changes in Earth's climate. In September, NASA selected 2 U.S. commercial providers, Boeing and SpaceX, to develop the systems to transport astronauts from U.S. soil to and from the space station, with a goal of ending the nation's sole reliance on Russia in 2017. Development of the rocket and spacecraft designed to carry astronauts on NASA's journey to Mars progressed in 2014. The green light was given in August to start building the Space Launch System heavy lift rocket, following successful completion of a key review. New manufacturing facilities began testing operations, and prototypes built with new, more lightweight composite materials were evaluated. In November, the fully assembled Orion spacecraft was moved to its launch pad at Cape Canaveral Air Force Station in Florida for its maiden flight test in December. NASA's fleet of Mars robotic explorers continued its work in 2014. The Mars Atmosphere and Volatile Evolution spacecraft arrived at the Red Planet in September as the newest member of the fleet. MAVEN is on a mission to investigate how the past loss of atmospheric gases impacted the Martian climate through time. Samples from the first rock drilled at the base of Mount Sharp by the Curiosity rover provided the first confirmation of a mineral mapped from orbit by the Mars Reconnaissance Orbiter. And the science instruments were selected for the Mars 2020 rover, the next robotic explorer NASA will send to Mars in 2020. It will conduct unprecedented science and exploration technology investigations, including potential habitability of the current environment and directly searching for signs of past life.
NASA's role in studying and protecting our home planet has never been stronger.
NASA Administrator Charlie Bolden called 2014 the Year of Earth for NASA, with the agency planning to launch 5 Earth science missions within a year's time. The first images from the Global Precipitation Measurement Mission, launched in February, of an extratropical cyclone illustrated the mission's ability to provide next-generation detailed observations of global precipitation. In April, NASA celebrated Earth Day with a hugely popular online global selfie postings from around the world to help promote environmental awareness. And the test data from the orbiting Carbon Observatory 2 mission following its launch in July confirmed the health of the spacecraft's instruments. OCO2 will help track our impact on the amount of carbon dioxide in the atmosphere and the various human-made and natural sources of CO2. 2014 included new discoveries, new intriguing mysteries, and new reasons to explore our solar system and beyond. In November, the European Space Agency's Rosetta spacecraft, which has 3 NASA instruments on board, successfully landed its Philae robotic probe on the surface of a speeding comet, the first ever soft landing of a spacecraft on a comet. And NASA's Kepler Space Telescope discovered a new Earth-sized planet in April, about 500 light-years from us, that also may have liquid water. The agency's premier aeronautics research centers continue to work on solutions to help improve the safety, efficiency, and comfort of air travel, while reminding people NASA is with you when you fly. A demonstration in November featured a wing that can change shape in flight. This could lead to technology for quieter and more fuel-efficient airliners. In September, NASA co-hosted an event that showcased 2 new technologies being evaluated that could improve takeoff time predictability of flights and help flight dispatchers choose more efficient routes around bad weather. And in May, NASA celebrated the renaming of its Dryden Flight Research Center to the Neil A. Armstrong Flight Research Center, and designated Hugh Dryden's name to the center's aeronautical test range. That's a look back at some of the top NASA stories of 2014. Keep up with us in 2015 on social media and at www.nasa.gov/TWAN.
So as you can see there, we've had a lot going on this year, and we're hoping to round it off today with a great launch and a great flight test for Orion. Liftoff coming up now in just 31 minutes. So let's go back now to Mike Curie for an update on our chances of being able to lift off at 7:05. Mike?
Brandy, everything continues to go technically and weather-wise. We will be standing by in just about a minute and a half for an update on the weather from 45th Weather Squadron Launch Weather Officer Kathy Winters, who will be briefing the team on the current conditions and the forecast for the liftoff time at 7:05 a.m. Eastern. Once we get through the weather briefing, which is at launch minus 30, a couple of other milestones that we'll be awaiting will be the terminal countdown hold, which occurs at launch minus 19 minutes, or the T-minus 4-minute mark. It's a planned built-in 15-minute hold during which managers will conduct 5 polls all around the country, and any final work that is required will be accomplished during that time as well. Also during that hold, the go-no-go, final go-no-go poll will send everyone off toward the hopefully planned liftoff at 7:05 a.m. today. And then we come out of the hold at T-minus 4 minutes and counting at 7:01. Liftoff planned again at exactly 7:05 a.m. Eastern Time. The Delta IV rocket stands on the launch pad at Space Launch Complex 37 here at Cape Canaveral Air Force Station with the flare stack burning away excess hydrogen that is vented overboard and carried away from the rocket through the umbilicals on the swing arms that you see. And then excess liquid oxygen is dumped overboard, and you can see the vapor at the top section of each of the 3 common booster cores. Standing by now for the weather briefing with Kathy Winters.
Roger, stand by for weather brief.
Standing by.
Roger, indicate ready for weather brief. LD.
LD ready.
OD.
OD ready.
And AFLD.
AFLD ready.
We'll proceed.
Currently, we are watching a cloud that moved off to the west, a shower. We had been concerned that that might cause an LCC violation, but it did pass and dissipate slowly dissipate as it moved to the west, enough to where we did not have to call an LCC violation for that. So we are still go on all constraints. Currently looking at our winds. Generally, we saw an increase about 2 hours ago. We saw an increase, but then generally it's been staying a little bit more steady with a little bit of a dip here in the last 30 minutes. Have not seen any wind violations over the past 20 minutes, although we have been gusting up to 21.4 knots here in the past 10 minutes. The constraint is 23 knots from the direction. That right now is still blowing right around 70 degrees. And this concludes the weather briefing. Unless there's any questions.
This RC, any anticipated change in direction, speed, or increase?
No, we think it's going to be remaining pretty steady when it comes to direction. An increase as we get closer to the end of the launch window, we may see a bump of a couple of knots on the wind. So I think the earlier portion of the launch window will be better than the latter.
So that was 070 degrees.
070 degrees right now, gusting around 21 knots, but I think during the window we could see 22 knots, and by the end of the window, 23 knots.
Copy. RC, no further questions.
Yeah, well, how about a ambient temperature, please?
Yes, ambient temperature 72 degrees for launch, 72.
Thank you. Other questions?
OD, no other questions.
AFLD, no questions.
Thank you, Owl.
So very good news from Kathy Winters. Once again, we are completely go, technically and with the weather. We're 27 minutes, 34 seconds away from launch, and we're going to hand it back to Brandy Dean. Brandy?
Thanks for the update, Mike. I got my fingers crossed. The Orion launching into space today is the first of its kind, and it's taken a lot of work to get it ready for today. So let's take a quick look back at the road that brought us here.
Preparing the Orion crew module for its first flight test in December actually began a few years ago. The crew module for Orion's flight test arrived at Kennedy Space Center in Florida in June 2012 and was transported to the Neil Armstrong Operations and Checkout Building High Bay for manufacturing, processing, and pre-flight testing. During the next 2 years, Orion prime contractor Lockheed Martin and NASA engineers and technicians built up the crew module from a green shell to a fully functional spacecraft. Many tests were performed to prepare Orion for its flight test. Orion's service module arrived at Kennedy Space Center and also was transported to the Operations and Checkout Building for build-up and processing. The module was completed with the installation of the fairings that protected in the early stages of launch ascent. Orion's heat shield, containing more than 200 instrumentation sensors, when installed. The heat shield will protect Orion during its re-entry into Earth's atmosphere and splashdown in the Pacific Ocean. Moving one step closer to the flight test, the Orion crew module was stacked atop the service module in June. Tile panels were installed around the spacecraft, and then both modules were put through their final system tests. On September 11th, the Orion stack was transported from the Operations and Checkout Building to the Payload Hazardous Servicing Facility. Inside this facility, the spacecraft was fueled with ammonia, hydrazine, and high-pressure helium ahead of its December flight test. The four major components for Orion's launch abort system, including the launch abort motor and the attitude control motor, arrived at Kennedy last year and were transported to the launch abort system facility for processing, testing, and integration. In late September, Orion was moved from the Payload Hazardous Servicing Facility to the Launch Abort System Facility. Inside the high bay, the Launch Abort System was lowered and attached to Orion. The system is designed to protect astronauts if a problem arises during launch by pulling the spacecraft away from the falling rocket. Orion waited inside the Launch Abort System Facility until the United Launch Alliance Delta IV Heavy rocket was ready for integration with the spacecraft. Earlier this year, the Delta IV core and starboard boosters arrived by barge in March and were offloaded and transported to the Horizontal Integration Facility near Space Launch Complex 37 at Cape Canaveral Air Force Station in Florida. The port booster and second stage followed in early May. The Delta IV Central Core Booster was mated to the port and starboard boosters. Then the Delta IV second stage was mated to the rocket's Central Core Booster. The Delta IV rocket for Orion's flight test rolled out of the Horizontal Integration Facility on September 30th and made the trek to the launch pad. In the early morning on October 1st, the nearly 180-foot-tall launch vehicle was carefully lifted into the vertical position and then raised into the mobile service tower on the pad. In early November, the Orion stack was transported to the launch pad and integrated to the rocket. Tests were performed to verify readiness for launch. After more than 2 years of work, Orion is now ready to soar on its first flight test.
As you can see, it's been a lot of work to get Orion to this point at Space Launch Complex 37, Cape Canaveral Air Force Station in Florida, and we are now just 23 minutes away from its launch. First time to head into space, check out its critical systems that we need to know work before we put astronauts on board. Once we do lift off, just a reminder that you'll be hearing a couple of different voices giving commentary here on NASA TV. That's going to be Rob Navius, Public Affairs Officer, who is standing by at Johnson Space Center in the Mission Control Center there in Houston, and also Steve Agin, who is the United Launch Alliance commentator for the day. He'll be giving ascent calls related to the rocket as well. Again, we are now just 22 minutes away from launch, and so I'm going to toss it back to Mike Curie to take us through liftoff. Mike?
Here's the winds aloft. Thank you, Brandy. At this time, there are some tests underway that were planned for today to cycle the fill and drain valves on the Delta IV Heavy liquid hydrogen tanks for each of the common booster cores. This was a process that was put in place yesterday after we ended up scrubbing near the end of the count because the fill and drain valves had been immersed in liquid hydrogen for a lengthy period of time and became sluggish. A determination was made that upon tanking today, and once we got close to the terminal count, they would operate the fill and drain valves. The launch team, the United Launch Alliance launch team, would operate the fill and drain valves occasionally to ensure that they remained flexible and able to close properly when we get into the terminal count. Earlier this morning, the liquid oxygen and liquid hydrogen was completely put into the tanks, both the liquid oxygen tanks at the top and the liquid hydrogen tanks at the lower section of the common booster cores. Once that was accomplished, we went into a topping mode to keep the levels consistent. And once we get into the terminal count, when we start counting down from T-minus 4 minutes, the fill and drain valves will close for the final time, sealing the liquid hydrogen and liquid oxygen into the tanks. And it's very important that they work properly. And they were not reliable yesterday, but again, it was brought on by the cryogenic conditions. What was determined today was that should we end up in the similar situation that we had yesterday in the terminal count, engineers will repressurize the liquid hydrogen tanks to 30 psi, pounds per square inch, which will force the fill and drain valves into the closed position, after which they will cycle them again for 5 times before we would go into a launch attempt recycle. They believe that this process will ensure that the fill and drain valves remain flexible and will be able to perform their job. This was a decision that was made through a series of telecons and meetings yesterday based on data that United Launch Alliance engineers produced following yesterday's launch attempt and the detanking that occurred afterward. We're at launch minus 19 minutes, 39 seconds, and a little bit more than 30 seconds away from entering our final planned built-in hold of the day at T-minus 4 minutes. Once again, it is a built-in 15-minute hold during which a number of polls will be conducted by managers across the country, and it will all hopefully culminate in a decision to go for launch at the beginning of our launch window today, which is about 20 minutes away from now. Standing by to enter the hold in 5, 4, 3, 2,
T-minus 4 minutes in holding. This is a 15-minute built-in hold.
Here at the Cape Canaveral Air Force Station in Florida at Hangar AE in the Mission Director Center, Mission Manager Brian Austin will be polling his team. At Kennedy Space Center in the Neil Armstrong Operations and Checkout Building, there are 2 control rooms, the Test and Launch Control Center and the Engineering Support Room. The Test and Launch Control Center is the primary Orion Launch Control Center, and it houses the Orion Launch Operations Team. Orion Launch Conductor Shane Roski will be polling his team. At Mission Control in Houston, Mike Serafin, Lead Flight Director, will poll his team. The Mission Control Center houses 4 areas that are supporting today's launch and mission. The Blue Flight Control Room, along with the Ops Suite, the IPOC, where imagery operations are led, and the Spaceflight Meteorology Group, which oversees splashdown weather. And in Denver, Colorado, an Orion or a Lockheed Martin facility that is supporting Orion for engineering data as well as support for post-recovery operations is the Remote Access Program and Test Operations Resource, or RAPTOR, and it's located in Denver, Colorado. There are 39 consoles there. They will be polling their group as well. And once all the polls are complete, everyone will give their go or no-go to Orion Mission Manager Brian Austin here at Hangar AE in the Mission Director Center, and he will provide a go.
17 minutes.
He will provide his go to United Launch Alliance Launch Conductor Scott Barney, who will provide a go to the United Launch Alliance launch team. We're proceeding through this built-in hold with no issues. The various circuits through which engineers and managers have been speaking all morning, very quiet. No issues are being tracked. Nothing significant that would stand in the way of launching today. And weather remains green.
Yeah, 5 hours.
Less than 16 minutes remain before liftoff of the Orion spacecraft on its maiden voyage. Orion launch conductor Scott Barney is conducting his poll at this time. Nearly 200 engineers and managers across the country involved in these polls. Launch minus 15 minutes. Orion reports that they are go. Mission Control in Houston, Flight Director Mike Serafin is conducting his poll. No issues there. He intends to give Mission Manager Brian Austin a go for launch. The Orion Engineering Manager is go for launch. All positions are reporting go. 14 minutes and 15 seconds before liftoff. Beautiful shot of Orion atop the Delta IV rocket, poised on the Space Coast and ready to begin its journey.
L-minus 14 minutes.
Node personnel report ready to enable T-4 limit conditions. EEA.
Ready. Ready.
Okay, you're very weak to hear, but I heard ready. PEA.
Ready.
T-4 limit conditions are on. SYS, verify alarms disabled and database modifications per red line memo and authorize real-time changes.
Verified.
MEQ, establish HAZGAS scan pattern 140.
Roger.
VSE, verify active with composite ramp temperature evaluation for current plan T0.
Verified.
VSE, verify base bending moment. Instrumentation is active and data is valid.
DBM system is fully mission capable. Recommend placard 6 alpha.
L-minus 13 minutes.
ALC, verify wind monitoring system set for placard 6 alpha.
Roger.
Orion Mission Manager Brian Austin has just completed his poll. All elements reporting to him are go. The final poll is scheduled to occur in about 5 minutes, when the United Launch Alliance launch director will conduct his poll. "12 minutes and 15 seconds before launch.
L-minus 12 minutes.
MEQ, initiate data logger just prior to the L-7 poll.
Roger.
ALC, start T4 master script.
Roger. Master script running.
Roger.
"11 minutes, 20 seconds before launch. All systems are go and weather remains green. Less than 11 minutes before launch. And a gorgeous view of the sun rising over the Florida coast. Once again, panning the camera from the top of the historic Vehicle Assembly Building, looking across the water to Space Launch Complex 37 at the adjacent Cape Canaveral Air Force Station.
RC, verify solar radiation limits acceptable for launch.
Verified.
Spectacular view.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds launch constraint any time after the terminal count status check, the observer shall